Hello, my dear students. Can we solve the questions? When the electron of a hydrogen atom jumps from n is equals to 4 to n is equals to 1 state, the number of spectral lines emitted is. Number of spectral lines is calculated by using the formula n2 minus n1 into n2 minus n1 plus 1 by 2, where n2 is equals to higher orbit number, n1 is equals to lower orbit number. Substitute 4 minus 1, 4 minus 1 plus 1 by 2. 4 minus 1, 3. 3 into 4 by 2, that is equals to 6. The mechanism of the reaction P plus Q gives rise to R as follows. We know that slow step is always considered as a rate determining step. First, take the slow step. P plus Q gives rise to A. Rate directly proportional to concentration of the reactants. Concentration of P into concentration of Q. Rate is equals to K into concentration of P into concentration of Q. In the original equation, P and Q are the reactants. In slow step also, P and Q are the reactants. Cases, reactants remain same, so fast steps are not required. Calculate the order of the reaction. According to the definition of order, sum of powers of concentration of reactants 1 plus 1 is equals to 2. The logarithm of the equilibrium constant of the cell reaction corresponding to the cell equation is given. Write the equation by using the cell. X is converted to x2 plus and y plus is converted to y. Reactants and products are balanced. Charge is not balanced. So take 2 moles of y plus 2 moles of y. X is converted to x2 plus 2 number of electrons are involved in this process. Calculate equilibrium constant. So the reaction is at equilibrium. Then only we are able to calculate equilibrium constant. At equilibrium, the value of E is equals to 0 condition. Then the above equation is also written as E naught is equals to 0.0591 by n log PPC by PRC is nothing but Kc. Calculate log Kc. Log Kc is equals to E naught into n by 0.0591. E naught value 1.2 into n value 2 by 0.0591. Simplify, then you will get 40.6. Which of the following upon electrolysis liberate O2 gas as major product at anode? Inert electrode means platinum or gold. These are considered as inert electrodes. CuSO4 in copper electrode. CuSO4 releases Cu2 plus ions. Electrode is also copper electrode. These are active electrodes. That's the reason B is ruled out. Concentrated HCl in platinum electrode. It liberates H2 gas and Cl2 gas. This is also ruled out. Remaining AgNO3 H2SO4. According to electrochemical principles, OH minus ions discharged at the anode much more easily than SO4 2 minus and NO3 minus ions. Why? These are aqueous solution. In aqueous solution, solvent is water. Water is dissociate like H plus and OH minus. In AgNO3 dissociate like Ag plus and NO3 minus. Yet two different type of anions are present. In this, OH minus ions discharged at anode much more easily. That's the reason A and D liberates O2 gas. Statement 1. For CH3COOH, I is equals to 1 plus alpha in an aqueous solution. In aqueous solution, Solvent is water. CH3COOH is dissociated. CH3COOH dissociate like CH3COO minus and H plus. How many number of ions are present? So number of ions is equals to 2 ions are present. Initial only 1 ion, finally converted to 2 ions. After dissociation, 1 cation and 1 anion, n value is equals to 2. Now n value 2 substitute, I is equals to 1 plus 2 minus 1 into alpha. I is equals to 1 plus alpha. Yes, statement 1 is correct. For CH3COOH, I is equals to 1 minus alpha by 2 when present in solution prepared in benzene. In the presence of benzene, CH3COOH undergoes association. CH3COOH undergoes association, then CH3COOH is converted to CH3COOH taken twice. Dimerization takes place. N value. How many number of products? 2 products. Dimer. N value 2. I is equals to 1 plus 1 by 2 minus 1 into alpha. I is equals to 1 minus 1 by 2 into alpha. I is equals to 1 minus alpha by 2. So second statement is also correct. Both statement 1 and 2 are true. Which of the following represents the arrangement in increasing order of bond order and bond dissociation energy? Bond dissociation energy. Bond dissociation energy. This is the bond order. Bond order of O2 is equals to 2. Bond order of O2 plus is 2.5. O2 2 minus is 1.0. O2 minus is 1.5. We know that what is the relation between bond order and bond energy? Bond order value is directly proportional to. So O2 plus bond energy is more. O2, O2 minus, finally O2 2 minus. So bond dissociation energy order is 1. Assuming 100% ionization of electrolyte in their solution, 0.1 molar NaCl and 0.05 molar BaCl2. Solutions are separated by semi-permeable membrane in container. For this system, choose the correct answer. Separated by semi-permeable membrane means here osmosis concept is involved. Here the concentration of BaCl2 solution is less. The concentration of, according to osmosis concept, is involved. In the given question, the concentration of BaCl2 solution is lower. Thus, solvent. What is the solvent here? Water is the solvent. Solvent water moves from BaCl2 solution to according to osmosis. At 298 kelvins, the values of Ka1 and Ka3 are given. Ka1, Ka3 values are given. Calculate the value of Ka2. First of all, H3PO4 is a polar protic acid. For polar protic acids, the dissociation constants follows the order Ka1 is greater than, Ka2 is greater than Ka3. Means Ka2 value is in between Ka1 and Ka3. The answer is in between these two values. Based on that, Fourth option is correct option. Read the following. Graphs are given. First graph related between rate and concentration in zero order reaction. We know that in case of zero order reaction, the rate of reaction is directly proportional to concentration of reactants. It is a zero order reaction, so power 0. That means rate is equals to K. Not depends upon concentration of reactants. So first graph is correct. B. Yes. B graph is given between concentration and time. Yes, for zero order reaction, B graph is also correct. C. Ln R time. This is also correct. First order reaction, what is the relation between half-life time and concentration of the reaction? Concentration of the reactants, half-life time of a first order reaction formula, T of is equals to 0.693 by K. That means half-life time of a first order reaction is independent on concentration of the reactants. All are correct graphs. In Lasson's extract of an organic compound, both nitrogen and sulfur are present, which gives blood red color with Fe3+ due to formation of blood red color, ferric thiocyanate. Assertion: a redox titration between KMnO4 and more salt. Solution in acidic medium is a self-indicator titration. Yes, KMnO4 is acts as a self-indicator. Reason: a redox titration between KMnO4 and oxalic acid. Solution is initially slow but becomes faster due to autocatalysis. This is also correct. A is true, R is true, but R is the not correct explanation of A. Why? In A discussed about more salt, in B discussed about oxalic acid. Which of the following sets of quantum numbers represent the 19th electron in chromium? Chromium 19th electron, 2 plus 2, 4, 10, 12, 18, 19th electron in chromium. The 19th electron is in 4s orbital. So n value is equals to 4. For s orbital, L value 0, m value 0, 4s1. First electron is in clockwise direction. So s value is plus half. Second option is correct. Match the following. Na2CO3 reacts with H2SO4. Then it liberates colorless, odorless, brisk effervescence. A, R. A, R. How many options? Only one option is there. If NaCl, MnO2, H2SO4 liberates Cl2 gas, it is greenish yellow color gas. Copper reacts with concentrated HNO3, NO2 gas is liberated, that is reddish brown gas. Na2SO4 reacts with BaCl2, then BaSO4 is precipitate is formed. BaSO4 is a white color precipitate. It is insoluble in concentrated HCl. During the conversion, NH2OH gives rise to N2O. The equivalent weight of NH2OH. Equivalent weight is equals to molecular weight by N factor. In NH2OH, oxidation state of nitrogen is -1. In N2O, oxidation state of nitrogen is +1. Difference, find out the difference, 1 minus -1. So 2. Molecular weight by 2 is the correct answer. The pH of solution obtained by mixing equal volumes. Volumes remains equal. So V1 value is equals to 1 ml. V2 value is also equals to 1 ml. N by 10 NaOH. N by 10 is nothing but 1 by 10 normal NaOH. So its normality is 0.1 normal. N by 20 HCl. 1 by 20 normal, 0.05 normal. Both are strong only. HCl is strong acid, NaOH is strong base. Which is in excess amount? Which concentration is more? NaOH concentration is more. So NaOH concentration is more. OH minus ion concentration is equals to NbVb minus NaVa by Va plus Vb. This is acid volume, this is base volume. NbVb 0.1 into 1 minus 0.05 into 1 by 1 plus 1. 0.05 divides with 2. OH minus ion concentration. Then OH minus ion concentration is equals to 0.025. It can be written as 25 into 10 power minus 3. POH is equals to negative log of OH minus ion concentration. Negative log of 25 into 10 power minus 3. Simplify. 3 log 10 minus log 25. 3 minus log 25 is also written as log 5 square. 2 log 5. Log 5 value 0.6990. 2 into 0.6990, you will get 1.397 like that. Now 3 minus 1.397, 1.603. But question is calculate pH. pH is equals to 14 minus POH. 14 minus 1.6 nearly equals to 12.4. First option. For the reaction AB gives rise to A plus B. Initial number of moles. Initially only reactants are present. So reactant 1 mole products 0 moles. At equilibrium. What is the condition is given? 33% dissociated. In 1, 33%. 133% means nothing but 0.33. 0.33 is also written as 1 by 3. 1 minus 1 by 3, 1 by 3, 1 by 3. Total number of moles at equilibrium. At equilibrium is equals to 1 minus 1 by 3 plus 1 by 3 plus 1 by 3. Minus 1 by 3 plus 1 by 3 cancel. 1 plus 1 by 3, that is equals to 4 by 3. Kp. Kp is equals to formula is partial pressure of A into partial pressure of B by partial pressure of AB. We know that according to Dalton's law, partial pressure is equals to total pressure into mole fraction. Mole fraction. How to calculate mole fraction? Mole fraction formula is number of moles of given component by total number of moles of all components. So based on that, partial pressure of A is equals to P into 1 by 3 divides with 4 by 3. Simplify. P by 4. Even partial pressure of B also P by 4 divides with partial pressure of AB. Partial pressure of AB is equals to total pressure into mole fraction. Number of moles of given component. Number of moles of given component is 1 minus 1 by 3, nothing but 2 by 3. Whole divides with total number of moles of all components 4 by 3. 3 cancel. And this is P by 2. P by 2. Now simplify. P by 4 into P by 4 into 2 by P. 2 times P cancel. Then P by 8. Kp is equals to P by 8. Then P is equals to 8 Kp. Compound A. Compound A. Compound A on treatment with sodium. We know that alcohols are easily reacts with sodium and it gives C2H5ONA, liberates H2 gas. Compound A on treatment with sodium gives B. I assumed compound A is C2H5OH, gives B, and it reacts with PCl5. Alcohols reacts with PCl5, then it gives C2H5Cl. This is C. Now B and C are react together gives diethyl ether. We know that alkyl halides reacts with a sodium alkoxide. Then it gives ether C2H5O C2H5. Then identify ABC. A is C2H5OH, B is C2H5Cl, and C is C2H5ONA. A is C2H5OH, B is C2H5ONA. Fourth option, not second option. Which of the following show highest magnetic moment? Vanadium 3 plus, remove 3 electrons. Then vanadium 3 plus electronic configuration is 3d2. Number of unpaired electrons is equals to 2. Cr3 plus, remove 3 electrons. Then electronic configuration is 3d3. Number of unpaired electrons is equals to 3. Fe3 plus, remove 3 electrons, 3d5. Number of unpaired electrons is equals to 5. CO3 plus, remove 3 electrons, 3d6. Number of unpaired electrons is equals to 4. Highest magnetic moment, n value increases, magnetic moment value is also increases. AgCl is dissolved in excess of each of NH3, KCN and Na2SO2O3. The complex ions produced in each case is, this is direct question. Then it gives AgNH3 twice 2 plus, AgCN twice 3 minus, AgS2O3 twice 2 minus. Anhydrous CuSO4 is white, but hydrated copper sulfate is blue in color. Correct. In the absence of ligand, crystal field splitting does not occur. Correct. Statement 1 is correct. Statement 2 is also correct. The correct order of field strength of the ligands: H2O less than, NH3 less than, En less than, Cn minus less than, CO. Third option is correct option. Which of the following element has positive E0 M2 plus by M value? Copper. Incorrect statement among the following is: the first ionization enthalpy of lanthanides is nearly 600 kilojoules. Correct. Both neptunium and plutonium exhibits maximum oxidation state +7. Correct. The transition metal present in the Ziegler-Natta catalyst is titanium. Correct. Europium has smallest atomic radius in lanthanides. Europium present here. Smallest atomic radius in lanthanides is lutetium. Only D statement is wrong. C2H5Cl reacts with KCN, then it gives nucleophilic substitution reaction takes place and it gives C2H5Cn. C2H5Cn undergoes reduction, then it gives C2H5CH2NH2, then it gives amine. This amine formula is C3579, C3H9N. This is in the form of C3H9N, 2-propanamine C3H9N, N-methyl ethanamine formula is also C3H9N, N-N dimethyl methanamine formula is also C3H9N. So correct answer is first option. We know that 1 degree, 2 degree, 3 degree amines are isomers, functional isomers. Which of the following is Ettard reaction? Second one is Ettard reaction. Match the following. Acid chloride reacts with H2PdBaSO4, then it gives aldehyde. A is Rosenman reduction. A Rosenman reduction, only one option. Now cross check the remaining. CH3CHO dilute NaOH. Aldol condensation, correct. CH3CH2COOH, carboxylic acid with alpha hydrogen atom participate towards HVZ reaction. CH3CHO, zinc amalgam, Clemmensen reduction. Alkynes reacts with 1 mole of NaNH2, then it gives CH triple bond C Na. Sodamide reacts with acidic hydrogen. After that, it further reacts with a CH3Br. Remove NaBr. Then it gives CH triple bond CCH3. HgSO4, H2SO4. Alkynes are undergoes hydrolysis. Alkynes are undergoes hydrolysis. Which type of hydrolysis? HgSO4, H2SO4 represents it is participate towards acidic hydrolysis. Acidic hydrolysis follows Markovnikov's rule. Add hydrogen atom unsaturated carbon which contains more number of hydrogens. CH2 double bond C OH CH3. Now this is vinyl alcohol. Vinyl alcohols are participate towards tautomerism. This is why vinyl alcohols are participate towards tautomerism. Proton is shifted towards unsaturated carbon which contains more number of hydrogens. Pi bond is shifted towards oxygen side. Then it gives CH3 C double bond O CH3. Ketone is formed. What is given? It forms yellow crystalline substance with I2NaOH. I2NaOH means it gives positive iodoform test. Yes, it gives positive iodoform test because it is a methyl ketone. It gives silver mirror test. No, ketones does not give silver mirror test. It is a functional isomer of acetaldehyde. Acetaldehyde formula CH3CHO. 2 carbon atoms are present in acetaldehyde, but here 3 carbon atoms are present. No, it forms oxime with hydroxyl amine. Yes, correct. Aldehydes, ketones both are reacts with oximes. A and D are correct. Chlorobenzene reacts with concentrated HNO3 H2SO4. Nitration takes place. Chlorine is the electron donating group, so substitute NO2 at para position, which further reacts with NaOH at 443 kelvins. The OH group replaces chlorine atom, then it gives OHNO2. ClNO2, OHNO2. Second option is correct option. Which of the following is correct? Maltose is disaccharide, correct? Amylose is water soluble, correct. Amylopectin is branched polymer, correct. Glycogen is animal starch, correct. Fourth option. Choose the correct option based on the following thermal reaction. C plus O2 gives rise to CO2, delta H is equals to minus X. C plus O2, CO2 gives rise to, delta H value is minus Y. Frame this equation by using first and second equations. In the final equation, graphite is the reactant. So reverse the first equation. Reverse the equation, then CO2 gives rise to C graphite plus O2. Change the sign. Delta H is equals to X. CO2 get cancelled. O2 cancelled. Then C diamond is converted to C graphite. Delta H is equals to X minus Y. C diamond converted to C graphite. Delta H value is given as delta H value shifted to reactant side, plus Z is converted to minus Z. Minus Z is equals to X minus Y, or both sides multiple with negative sign, Z is equals to Y minus X. Second option is correct option. A process is non-spontaneous at the freezing point of water. Freezing point of water. Freezing point of water. Temperature decreases. Low temperature is required. Okay. Now, non-spontaneous. In non-spontaneous condition, delta H value positive and delta S value negative. Delta H value positive, delta S value is negative. Temperature is low temperature. If we are using at low temperature, the T delta S value is decreases. If T delta S value is very less, suppose positive value taken as plus 4, at low temperature T delta S value is decreases. The value is taken as 2. Then you will get plus 2. That means delta G value is positive. I assumed 4 2 values. So, but it becomes spontaneous at boiling point. Boiling point, water boiled, then temperature increases. Temperature increases means high temperature is required. Delta G is equals to delta H minus T delta S. Spontaneous condition, delta H value is negative minus temperature into delta S value is positive. Temperature is increases, the positive value is abnormally increases. Compared with negative value, positive value is abnormally increases. So here also you will get positive. Both are positives. C6H5CH2Br reacts with magnesium in the presence of ether. Then it gives Grignard reagent C6H5CH2MgBr. Now Grignard reagent reacts with water. Grignard reagent reacts with water. Water is the active hydrogen containing compound. Water provides H plus ions. H plus and OH minus. It dissociates like Mg plus, carbon gets negative charge. Remove MgOHBr, then it gives C6H5CH3. Methyl benzene. The following: fluorine greater than, chlorine greater than, bromine greater than iodine. That is the electronegativity order. We know that in 7A group, second element electron affinity value is more compared with first element. Electron gain enthalpy. Next one, bond dissociation energy. Bond dissociation energy 143, 199, 228, 266. Here values are given, check it. Bond dissociation energy of fluorine is less compared with chlorine and bromine due to repulsions. Finally, oxidizing power, groups top to bottom, oxidizing power is decreases. Ionic trihalide among the following is ionic bond is formed between cation and anion. First favorable condition is cation with large size. Which atomic size is large? Nitrogen, phosphorus, arsenic, antimony, bismuth. Same group elements, bismuth atomic size is large. So it forms ionic compound easily. Among the following, the order of decreasing SN1 reactivity. Now you can check it. It follows 4n plus 2 pi electron rule. It is aromatic, more stable. This compound follows 4n pi electron rule, anti-aromatic. Aliphatic bromide. SN1 reactivity. SN1 reaction intermediate is carbocation. Which is more stable? Aromatic is more stable. So 1. Aromatic after aliphatic, aliphatic after anti-aromatic. Second option is correct option. Depends upon order of stability of carbocation. Order of stability of carbocation, aromatic carbocations are more stable. After that aliphatic, finally anti-aromatic. Order of stability. Aromatic compounds are more stable, or aromatic carbocation is more stable. After that aliphatic compounds or aliphatic carbocation. Finally anti-aromatic compounds or anti-aromatic carbocations. Identify X in this equation. Okay. 3n, n represent neutron. Neutron, 3 moles of neutron, that means N01 plus N01 plus N01. Total mass number is 297. Product side mass number is 297. Reactant side mass number is 249. If you can add 48 to 249, then mass numbers remains the same. Product side atomic number 118, reactant side 98. You can add 20, then atomic number sum is also equal. So second option is correct option. Phenol undergoes nitration, then it gives more volatile compound, less volatile compound. More volatile compound is orthonitrophenol, less volatile compound is paranitrophenol. Why? Because of hydrogen bond. In orthonitrophenol, intramolecular hydrogen bonding is formed, but in paranitrophenol, intermolecular hydrogen bond is formed. Correct. Increasing order of electronegativity of carbon, nitrogen, silicon and phosphorus. We know that groups top to bottom, electronegativity decreases. Groups top to bottom. Nitrogen, phosphorus, nitrogen electronegativity is more. Carbon, silicon, carbon electronegativity is more. Periods left to right, electronegativity increases. These two are period elements. Left to right electronegativity increases. So first nitrogen. Nitrogen electronegativity is more. Yes, third option is correct option. Which of the following compound will have optically active? Which compound contains chiral carbon atom? Then the compound is considered as optically active compound. Yes, 2-bromobutane chiral carbon atom is present. So this is optically active. Remaining cases there is no chiral carbon atom. So remaining compounds are optically inactive. Correct statement among the following. NO2 minus ion contains 12 non-bonding electrons. 12 non-bonding electrons. First of all, calculate total number of valence electrons. Total number of valence electron. Nitrogen contains 5 valence electron. Oxygen contains 6 valence electron. Second oxygen is also contains 6 valence electrons. And negative charge NO2 minus negative charge contains 1 valence electron. Total number of valence electrons 18 electrons are present. Here question is calculate the non-bonding electrons. If you want non-bonding electrons is equals to total number of electrons minus bonding electrons. Here total number of electrons is equals to calculated 18 electrons minus around this how many bonds are there? 1, 2, 3. In NO2 minus structure 3 bonds are present. Electrons 3 2s are 6. 18 minus 6 12. So first statement is correct. In ozone formal charge on central atom is +1. Central atom formal charge is +1. Formal charge is calculated by using this formula. Group number of oxygen is 6 minus number of valence electrons in oxygen. Number of lone pair of electrons. Number of lone pair of electrons. On oxygen atom, 2 lone pair of electrons are present. Minus 1 by 2 into how many bonds are there around the central oxygen? 3 bonds are there. Number of bond pair of electrons, 3 bonds contains 3 2s are 6 electrons. So 6 minus 5 plus 1. This statement is also correct. In ClO4 minus ion bond order is 7 by 4. In case of polyatomic molecule, bond order is equals to total number of bonds in a structure divides with number of resonance structures. This is the first possible structure. Next possible structure, initially O minus is top. Now O minus is present at right side. In the next structure, O minus is present at bottom. In the next structure, O minus is present at left hand side. So total possible structures is equals to 4. Number of bonds in a structure is equals to 1, 2, 3, 4, 5, 6, 7. Total number of resonance structures 4. 7 minus, sorry. So bond order is equals to 7 by 4. Correct. A correct, B correct, C correct. Formal charge of oxygen is -1. Check it. Oxygen group number. Group number of oxygen is 6 minus how many number of lone pair of electrons are present? In CO molecule, oxygen contains one lone pair of electron, one lone pair. So 2 electrons are present minus 1 by 2 into how many bonds are present? 3 bonds. Electrons, 6 bond pair of electrons. 3. 6 minus 5. 6 minus 5 is equals to +1. So fourth statement is wrong. Only A, B, C are correct. The increasing order of atomic radii of the following group 13 element. Group 13 element atomic radius order. Boron greater than gallium greater than aluminium. Here boron is not mentioned, so neglect boron. Gallium greater than aluminium. Second option is correct option. Electronegativity order. Boron greater than thallium greater than indium greater than gallium greater than aluminium. More electronegative element is boron. Less electronegative element is aluminium. Identify the correct product. Alkene HBr follows Markovnikov's rule. First add hydrogen atom from HBr to unsaturated carbon which contains more number of hydrogens. Then it is converted like this: CH3C, CH3, H, CH, positive charge, CH3. Now carbocation, formed carbocation is 2-degree carbocation. Adjacent a 3-degree carbon atom is present. That's the reason hydride shift takes place. CH3, CCH3, positive charge, CH2, CH3. Now you can add Br minus, then you will get CH3C, CH3, Br, CH2, CH3. Here hydride shift takes place. Why hydride shift takes place? Compared with 2-degree carbocation, 3-degree carbocation is more stable. Based on that, fourth one is correct answer. Which of the following is not possible? Okay. Dehydration. Remove water molecule. Remove water molecule. Remove hydrogen atom from beta carbon atom. Suppose if you can remove here, how many number of beta hydrogen atoms, beta carbon atoms are present? This is beta, this is beta, this is beta. Suppose if you can remove hydrogen atom from right side beta carbon, then this structure is possible. Suppose you can remove hydrogen atom from top beta carbon atom, then this structure is possible. Suppose if you can remove hydrogen atom from left side beta carbon atom, then this structure is possible. Which structure is impossible? First structure is impossible. With respect to the conformers of ethane, which of the following statement is true? The bond angles and bond lengths remains same. So not fourth option. Bond angle and bond length remains same. Third option is correct option. IUPAC name of the compound. 1, 2, 3, 4, 5 carbons. Methyl starts with M, hydroxy starts with H. Based on the alphabetical order, 4 hydroxy, 2 methyl, pent 2 in, 1 all. Second option is correct option. Thank you.